Good morning, students. My name is Nimal, and I will be the lecturer for this course, Computer Interfacing and Microprocessors. Today is the first lecture that I'm meeting you all. I have not done any previous modules with you. So I will just briefly introduce myself, and then we can get on with the lesson. And also, before starting, we will probably towards the end of the lesson, we will talk about some logistics related to doing these online lessons and so on. So, about me, my name is Nimal. I'm a senior lecturer permanently attached to the University of Sri Jayewardenepura. I was originally an engineer, and software engineering was my background, computer engineering, and now I'm attached to the Faculty of Technology at University of Sri Jayewardenepura. In terms of my background, I'm also, in addition to computing, I'm also into networking and computer security from a research and teaching point of view as well. And I also teach a number of subjects related to computer hardware, and this subject is one of those subjects. I guess we could get started with the lesson, and while we are going along with the lesson, if you have any questions, feel free to either you could put it as a message on the chat window, and I will check that frequently, and I will answer those questions, or you could also unmute yourself and ask the question. That is also fine. Yeah. So in this particular course, we have a number of things that we are trying to achieve, a number of things that we want to cover. So the main one is you would have gotten some foundation, some background into computing in a number of previous modules that you have followed. In this one, we are going to go a bit more deeper into understanding how microprocessors work, and how those are interconnected with the various other computers in sort of from a hardware perspective. But also we are going to be thinking more from a programmer's point of view in terms of how the programmers are going to program these computers, and how various instructions can be given to those computers, the hardware parts of the computers, and how those can be executed, or how we can produce computations, or we can produce computable results out of them. So that interaction between that hardware layer, the various hardware components that we may have in a computer, and the software layer is what we would identify as interfacing. So that is the things that are sort of the main things that we are focusing in this particular course. But we will not be particularly focusing on any sort of detailed hardware designing aspects. We will be thinking about the existing hardware modules. We will talk about existing hardware designs, existing microprocessor designs, various sort of key components of microprocessors, and so on. But we will not go into the details or the theory behind how these things can be, how the various hardware components can be designed. So the designing aspect is not something that we will be focusing on. Also, we will not be focusing on any high-level programming languages, even though we say we are talking about the interfacing between software and hardware. We will not talk about the high-level programming, but we will only be focusing about the sort of low-level programming and how that is interacting with the hardware layer. So that is the scope of this lecture. But there is the expectation that you have covered some of the sort of fundamental programming modules in the previous years. So you have some introduction into programming, how the basic sort of high-level programming languages such as C or C++, how you can program using one of those languages is an expectation that is there as a prerequisite for this module. So when we say a set of prerequisites for this module, we expect some understanding of C or C++ type of a programming language, some understanding of basic computers, or what we call as von Neumann model computers. So that is memory, input, output, processing, and how those components are interconnected. So that the basic understanding of that, and some basic understanding of various concepts like instructions, instruction sets, addressing and memory, and sort of other memory modules such as mass storage and input-output devices. So these are some of the things that you may have covered in some of the previous modules, and some of the knowledge from there will be useful in the various topics that we will be discussing in this module. We may go back to sort of refreshing some of these topic areas, but the expectation is that we have covered these in more detail in those previous modules. So we will not go into much more detail around these topics in this course. So we will start today's discussion by again going back into some of the things that you may have covered previously, and sort of we will recap on some of those topic areas, and that is the main thing that we'll be doing in today's lesson, and in the coming weeks we'll go into some of the newer topic areas. So when we say computer architecture, what we are talking about computer architecture. So we talk about computer organization, we talk about computer architecture. So for example, a von Neumann model is a computer, like you talk about various components that are necessary for a computer. So there are such models exist. Then when we talk about computer architecture, we are mainly talking about how the various components, the various basic components that we understand are the foundation of a computer, how these things are arranged, how the various components are arranged, and in what ways, and how those things come together to make a computer. So we can think of this in a sort of a day-to-day example of any architecture of a building, for example. We may have certain expectations. Say if it is a house, we may have certain expectations of it having certain components, or having certain rooms. So those are what we expect in a home. But then the actual architecture, actual design of that home can take many different forms. So we can have a number of different rooms in different arrangements. So that is the main difference when we talk about computer architecture as well. So when we say this is the model that we are following, this is the von Neumann computer, but regardless of that, we can have a significantly different architecture in terms of the processor that we use, in terms of the memory that we use, and how the various interconnections are happening. So some of these things will dictate what is the nature of the architecture of that particular computer. So the main difference between computer architecture and computer organization would be, the architecture would be the higher level description of how the various things are implemented, particularly from a programmer's point of view. So this would say what are the instructions, what are the registers, what are the memory addressing schemes, and so on. Whereas the computer organization, we can see it as more of a detailed implementation of a said architecture. So this would dictate like how much memory, how much cache memory, for example, uh, what is the sort of what are sort of the different implementation technologies that are used there. So that would be the computer organization. So that is the main difference between these terminologies, and in some ways these terminologies get used sort of in a sort of convoluted manner. They may sometimes even be used interchangeably to mean sort of similar type of things, but there is a slight variation between when we say computer architecture and when we say computer organization. So a good example would be we can have a number of processors, a number of microprocessors that may follow the same architecture. So all the say core I sort of processors may follow the same architecture. So they may support the same instruction sets and so on. So they may follow the same architecture, but each version of the processors, each variation of the processors may have significantly different underlying implementation. So they may follow the same architecture but different organization. So that's why the different microprocessors may have different speeds, and so there could be a number of variations that we could observe in these processes, and the reason for that is they have different organization there. So now if we again go back to some of the things that you may have covered previously as well, the basic computer or a basic von Neumann computer, or an extended version of that, and some of the key components that we would have in such a computer. So in the scope of this course, we are mainly talking about microprocessors and microprocessor interfaces. But beyond that, there are a number of other components that we will sort of occasionally interact with. So we will have an overall overview of a computer system, and then we can sort of have a understanding of what are the various things that we talk about when we are discussing various other things. In a sort of a typical computer, the key component or the central component is the central processing unit or the CPU. So it is the one that is going to do all the processing, all the computation. So hence it becomes the core component of the computing device. But in addition to that, we can identify two other components that are that we can say are sort of two other important parts. One is memory, so that is where information could be stored, and input-output devices or input-output controllers through which the information can come into the computers and go out of the computers. So what we may have is, so the basic components of the CPU would be the one that we would have as the central part, but we could also identify memory and input-output controllers as the two additional components that are also key to a computer. So we could identify these three as the basic components. But then we could also identify certain other things. Say, with CPUs, there would be additional cache memories. We could attach input-output devices to input-output controllers, and then in most computers, we would have some ways of interconnecting these things, and we may use sometimes a bus to interconnect these devices. So likewise, we may have sort of few different approaches, few different components and approaches interconnecting in a typical computer. So again, if we think about the central processing unit, again, in the central processing unit, we can identify a number of components. So we would have the arithmetic logic unit, which is the component that is going to do all the computations. All the calculations are going to be happening in the arithmetic logic unit. Then any sort of temporary data that is being processed by the arithmetic logic unit are going to be stored on the registers. So the registers are temporary memory locations that are available inside the central processing unit. Then we may have an input-output unit that is responsible for communication to the outside world. So the processor needs to communicate to the outside components. It needs to receive information, send back results. So it needs to have some form of communication happening. So that can be identified as the input-output unit. And then we would also have what is called a control unit, which is going to control what is happening in the processor. So the arithmetic logic unit is the component that is going to do computations. So the actual calculations that we request the processor to do will be done by the ALU, whereas the control unit will do computations or operations relevant to managing that process. So it is going to keep time, identifying what is the instruction currently being executed. So those things will be the responsibility of the control unit. So we can identify these four components as sort of key components inside a central processing unit. So among those components, registers are one of the important ones. Again, we will be revisiting, particularly when we are talking about microprocessor interfacing. When we are talking about the computer from a programmer's point of view, we need to know how much information that we can store, where we can store this information, and how those information can be taken and processed. So the registers and how many registers that are there inside a central processing unit will become important for a programmer. So we will be revisiting this in a number of other topic areas as well. And registers can be, some of these registers can be directly used by the programmers for the purpose of communicating with the hardware. So any information can be forwarded or temporarily stored in these registers. But some registers may also be used by other things, such as to keep count of where the program is, or the program counter, or additionally some may be used by operating system or other underlying systems to manage the overall operation of the computer. So we may have additional types of registers as well, but in generally we will have the main purpose of these registers would be temporarily storing information before and after processing, after computation. And how many registers and what type of registers and how much information can be stored on those registers will decide what is the nature of programs that we can design for the computer, the nature of interaction that can be there between the software layer and the hardware layer. So registers become an important part of this overall structure that we are discussing. Then we would have what are called buses. So again, these are some things that you may have covered in the previous lessons, previous modules. But just to recap again, because we will be revisiting these things when we are discussing interfacing and so on. So buses are basically what we can identify, the name that we give to a parallel set of wires or a set of wires that have a particular purpose. So what we mean by that is, so say if we are interconnecting two components, normally we interconnect them with a number of wires. So inside a computer. So then if we have a group of these wires and if we give them a particular purpose, or if those wires have a particular usage, then we may call that as a particular type of a bus. So typical buses that you may encounter in computers could be like control bus, which can carry information relevant to controlling other devices or information relevant to controlling these different components. Address bus may carry information about memory addresses, which address to read from or write to. And the data bus is what would carry information that is going back and forth between memory and CPU or memory and input output devices and so on. So all these things may be interconnected through different types of buses for different purposes. And one of the other things with buses is buses will be shared by a number of components as well. So these are not like a direct connection that we may have between two components, but these are more like shared connections that are going to be shared by a number of components. So the same control bus may be used by different components within the computer, and they may have to be shared on a time basis. For example, a bus may be allocated to a particular device for a period of time, and that it may communicate some information, and then it may be allocated to another device. So that is the main sort of type of usage that we would have when we are using buses. So it will be shared among a number of users. They will have a particular purpose, what they are doing, so whether it is an address bus or a control bus or a data bus, and then what type of information that is being carried and from where to where, and that can also change. Say for example, we may send something from memory to CPU through a data bus. Some information is being carried from memory to CPU before the processing of information happens, but once the data is processed and the results may again transfer back through from CPU to the memory. So the same bus can carry information in different directions as well. So this is something again we will revisit when we are discussing about interfacing particularly. Then another component that we would have in any sort of typical computer is various input-output controllers. So whatever the devices that we attach to computers, whatever the input-output devices that we attach to computers, we need to have some way of communicating with them. But the reality of modern computers is, the reality of a typical computer that we would encounter these days is, they are made up of a significantly diverse set of devices. So they are interconnected to a diverse set of devices. So if you think about, let's take an example of a typical computer that you may be using now. If you are using a computer, so could be a laptop or a desktop computer or even a smartphone for that matter, they will have a number of input-output devices and a number of different input-output devices. And say you may have things that are connected through USB, you may have things that are connected through PCI. So there can be various different ways these are attached to the computer. So then we would have something that is going to manage how these things are communicated with. So the microprocessor can't be responsible for doing all the underlying communication with the variety of hardware components that we may have. Say it may need to communicate to a projector, it may need to communicate to a screen. So different communication requirements will be there, and the microprocessor will not be doing that directly. So it will delegate that responsibility to some other component, and that is what we identify as a input-output controller or set of input-output controllers. So we may have some controllers that will manage the disk drives. We will have some other controllers managing the display drivers. There will be other controllers that are managing sound devices. So, and all these input-output controllers will have their own responsibilities, and they will manage a set of devices, and together all these devices and all these input output controllers, the CPU will be able to communicate to the variety of devices that we have connected to those I/O controllers. So in many ways we will have these I/O controllers as sort of independent in many ways they may also have additional processing capabilities built into them. So they may also not rely on the CPU, the main central processing unit, or the microprocessor, the central microprocessor, to do their computations. Rather, they may have their own processor as well. So a typical example could be the a GPU, for example, a graphics processing unit in a computer. So that in itself is can be a particular processor that is separate from the CPU itself, and some of the computation can be delegated to that particular I/O controller as well. The I/O controller may be given some information, and then it can do some processing and then pass that on to the device that it is connected to. But one of the other things that we would see with input-output controllers, and that is relevant to again our discussion around computer interfacing, would be the ability or the need for computers to communicate with input-output devices, and also then the input-output devices to communicate back to the CPU. Say, for example, the CPU may have requested certain action from an input-output device, and then once the action is being carried on and it is completed, then the input-output device may need to communicate back that information to the CPU. So whatever the program may continue processing based on that. So that is where we would have things like interrupt processors, and so on. So again, these are some of the things we may revisit again, but also some of the things you may have covered previously as well. So then another concept that you may remember from previous modules is what is called a memory hierarchy. So what we would have in a typical computer is, so we already identified that there are going to be some registers inside a computer that is going to hold some temporary data while processing is happening. So before and after processing, we may move that information to and from the registers. Then we also identified there are some other memory that is there, memory as sort of the other key component relevant to the basic computer. Then if we think about all the various types of memories that we can have in a computer, we will have this concept of a memory hierarchy, where we have these different types of memories, these different types of memory technologies, and they have different roles in a computer. So what we may have is, we may have registers that are inside a CPU that are used as sort of intermediary temporary locations for data processing. Then we have some cache memories. We can have a main memory or a RAM. We can have a secondary storage, and we can even have removable storages depending on the nature of the computer. But one of the common things that we may encounter with this approach is what we can think about when thinking about the speeds of these devices, how fast we can read and write information from these devices. But also another thing that you may observe with this is, even when thinking about your own computers, you may identify like these different types of memories are available in different amounts or different quantities. We may have a certain number of say certain GBs or terabytes of secondary storage, but we may have somewhat significantly smaller amount of the main memory. And if you think about the particular processor and the underlying computer component, you may also identify it may have even smaller cache memory, and then the registers are going to be even smaller. So we are going to have some differences in that sense as well. So one of the two things that we would identify here is, we would identify that as we go down in this memory hierarchy, the available amount of space or the storage, the size will increase as we go down the hierarchy. But on the other hand, if we go up the hierarchy, we may also observe that the speed of these devices will increase as we go up the hierarchy. And from an economical point of view, we may also see that the price may also go up when we go above in the hierarchy. So one of the things to remember is, there will be different types of memories in a computer, and they may have different purposes. And then when we think about the computer from a programmer's point of view, we have to think about what is the type of memories that we can get and how we can effectively use these different sets of memories effectively and interchange, like how we can move information from one to the other in a more suitable manner. So again, this is something that we may revisit in some of the other discussions as well, when we are talking about memory and how we are using the memory and so on. So one of the other things that we would talk significantly in this particular course is about the instruction cycle. So how a program instruction will be executed in the microprocessor. So as we said, the main idea, the main aim behind the course, behind this course, the main topic areas that we'll be covering is the hardware software interfacing and how it is going to impact the programming. So that is the main focus here. So when we think about programming and when we think about the execution of programs, one of the things that we will think about is how the instructions are going to be executed one after the other. So that is where we have the concept of an instruction cycle. So an instruction will go through a set of stages in terms of when it gets processed in the microprocessor. So starting from a fetch cycle, where the instruction is being taken out from a memory location and loaded onto the microprocessor. Then the received instruction then will have to be decoded to identify the various parts of the instruction, the opcode and the operand and so on. And then it will have to be forwarded to the appropriate component of the arithmetic logic unit, to the appropriate operation, and then it will have to be executed, and whatever the results will have to be transferred back to the appropriate destinations or the given destination. So this basic instruction cycle is something that we will discuss quite a bit later on as well. So because from a programmer's point of view, this is what the main interest would be. So we may have a set of instructions that we are writing as part of a program. Then we are interested in how these things are taken into the processor, how they are processed, and how the results are being produced, and then those results are forwarded onto the main memory or wherever it needs to go. So that basic process of executing instructions one after the other through this instruction cycle is something that we will be interested in from a programmer's point of view. So when we think about the most simplest form of instruction cycle, we can think of these three stages. We will have the instruction will have to be fetched from the main memory initially, so that we can identify as the fetch cycle. It is being fetched from the main memory, but the instruction. Then once the instruction is there, then we will have to get whatever the relevant operands for that as well. So we will have to go and fetch the operands that are relevant to that instruction, and then the execution can happen. So as an example, if we have an instruction that says we are going to do, say, add a comma b, so that is the instruction that we have to add two values, then when we are fetching the instruction, we would fetch add, and when we are fetching the operands, we would go and identify where these things are stored in the memory, either memory or cache memory or wherever. We will go and find that particular value. Say a and b can have particular values, so then we will go and fetch those values relevant to that instruction, and then that can be forwarded on to whatever the component inside the ALU that is responsible for the add function. So that is the basic steps that we would take in a sort of a simpler view of an execution. Then if we think about computers in a sort of a layered structure, when we think about computers in this sort of a layered architecture, we can identify a number of different components, and we would be interested in different one of these components in sort of for different reasons. Some of these things, the main sort of differentiation that we can have between these things would be sort of separating them as hardware, part of them as hardware components and part of them as software components. So we can identify some of these are software components and some are hardware components. Then within the hardware components, we will have sort of the very underlying structures of the hardware. So the basic physical structure of the materials, then up to building sort of basic components such as transistors, and then using that we come to the layer of building gates and registers. Then we can have the microarchitecture, so that is the microprocessor architecture. Then we will have the instruction set architecture, and beyond that we would have machine code and so on. So we go into the software realm after that. So with that understanding, in this course we are mainly going to be around the areas of these three, maybe touching upon assembly language programming for a bit, but other than that we are mainly focusing on these four components: microarchitectures, instruction set architectures, machine codes, and to some extent assembly language programming. As I said, anything above that in terms of high-level programming languages and other software-related things, we will not be interested so much. We may discuss some aspects of operating systems and so on towards the end of the course, but not in a significant detail. Similarly, we are not going to go into detailed hardware discussions as well, related to registers and how the microarchitecture is implemented. So very underlying underlying level of hardware, again, we are not going to discuss in this course. Then one of the other things that we could discuss today is the understanding or the differences between microprocessors and microcontrollers. So again, this difference is not important for the particular scope of this course, but it is something that you need to know as well. We are going to be focusing on the microprocessor part and the interfacing part as the main discussion points throughout this course, but there are certain other things relevant to that may be important to you. So that is what we are covering in this discussion. So when we say a processor, so that is the underlying processor that we would have in any sort of computer system. So that is why any sort of programmer, any computer designer should know and understand what is necessary in terms of the processor. So that is why we are studying about processors. So that is the basic microarchitecture of the processor that we are going to discuss. But from a microprocessor point of view, we are also talking about some of these other components around that. So we are talking about the additional components that are in the CPU, but also some other additional components that are interfacing with this microprocessor and which makes up a broader computer. So as we identify these basic components and how those things are interfacing, so that is the microprocessor. But then we have the concept of a microcontroller, and that is taking up even more components, more of these components that it is normally a microprocessor is normally interfacing with, and putting all of them into a single package. So the main processing component and some other components together on a chip, we identify that as the microprocessor. Then microprocessor is again connected to memory and input-output devices and number of these components. And now if we can also put those things into a single package, then that becomes a microcontroller. So essentially a microcontroller, we can see it as a functional computer. So anything that is necessary for a computer to function, the basic components of a computer are going to be inside a single chip. So we would identify it as a system on a chip. So it will have all the components necessary for us to build a computer. So we may need to still have some other components, some other input-output devices may need to be connected to the microcontroller, but it is going to have a large number of those other components built into that same system. So, so we may connect some input-output devices, maybe even some additional input-output controllers, but the key components or the basic components are part of the microcontroller. So there are a number of examples of microcontrollers, and as I said, we may not focus on microcontrollers in this course, but you may come revisit those when you have a module such as a embedded systems or a similar module. You may revisit microcontrollers, but in this course we will be only focusing on the core processing part of it. But the same concepts that we study in this course will be transferable to microcontrollers as well, because the main difference is those are put in a different type of package, but conceptually these concepts are transferable between different types of microprocessors and microcontrollers as well. So when we think about microcontrollers and microprocessors, sort of the key differences that we would have, or the key differences that we can see, are relating to how these things are organized, where these things are organized. So because the microprocessor will have only a limited number of components as part of it, whereas microcontroller will have a large number of things, large number of components as part of it. But that also means microcontrollers will be able to communicate with these components maybe in a much more effective manner, because they don't need additional interconnection. These things are directly connected, so to speak, whereas microprocessors may have certain limitations in terms of those communications. But one of the other differences that we may see is microprocessors may have the advantage of being able to change these other components, whereas microprocessors will be fixed in many ways. So the various other components that are included as part of a microcontroller can be optionally changed in a microprocessor. So what we may have is, in a microprocessor environment, it may be possible for us to change these components. So we could say we have this component, we have these things that we are covering here, and we can change the other parts. So we can change the amount of RAM we have in the device. We can change the type of input output we can have. So there can be a number of these things can be changed, which may not be possible in a microcontroller. So also in terms of users or use cases, we will use microprocessors instead of general purpose computing applications, and microcontrollers in a more sort of application specific systems. So again, as I said, we may not revisit this microcontrollers and microprocessors in the latter part of this course. We will still talk about microprocessors, and whatever that we discuss about microprocessors is still relevant to microcontrollers because they also have a microprocessor inside them. So beyond that, we will not be discussing too much about microcontrollers in the rest of this course. So now let's get back to what we are going to cover in this course. So again, the same sort of similar sort of structure of various things in a computer. If we break them into these type of components, we can identify sort of number of key components here, like some number of hardware components and number of software components. Among the hardware components, we are going to be studying about microprocessors because the course is computer interfacing and microprocessors. So we are definitely going to study about microprocessors, but also we will talk about and we'll cover memory and input output devices significantly, because the various topics that we will be discussing will have significant bearing to memory and input output devices. Then on the software side of things, we will mainly talk about assembly language programming and assembly and machine language based on instruction set architectures, and we will also talk about some aspects of operating systems. Beyond that, anything relevant to application software is not something that we will be talking about in this course. Then if we think about it from a programming point of view, or when we think about it in a programmer's different levels of programming, different levels of programming representation, again we can see what our focus would be around, say, machine language programs and assembly language programs. So this is something, again, if you may recall, like, say, in a typical high level programming language, you may program instructions, program code lines like that, and then how that can get translated into an assembly language program, or how that may be represented again in a machine language program, and so on. That is what we will be talking about in this course. And then again, there's what happens to that after that inside the microprocessor from a control point of view. We may not be focusing too much, because that is again the very low level hardware implementations. We are not going to be focusing there as well. So that is a brief introduction about the various topic areas that may be relevant to this course. And as this is an introductory lecture, we are not going to go into any other detailed topic areas. We will start. The next topic that we will be starting is number systems, the digital number systems, and I think we could start it on a new lecture next week, so that would be much more appropriate. Are there any questions on things that we discussed so far? Particularly, please let me know, because I have covered a number of different topic areas, and I have sort of mentioned that these are things that you may have covered previously and so on. And my understanding of that is based on your syllabus, based on the modules that you have according to your course coordinator. I was provided a set of modules that you have covered previously. So this is based on that. But if there are any differences, if you have not covered certain things, or if you have covered certain things in a significant detail, please let me know, so then I can use that information to restructure the courses in the coming weeks. Kobi, kayu madi kono mundu tibena kana betu. அதுதான் நம்ம நிப்பாட்டிட்டு வெயிட் பண்ணிட்டு இருக்கேன். So if there are no other particular questions, we may go on to discussing the course details. So these are some of the topics that we will be focusing on in this course. So these are the sort of the set of lecture topics that we will be covering in the coming weeks. So we'll go through, we'll start with digital number systems, and we'll go on to microprocessors, sort of hardware, sort of underlying microprocessor hardware related things, then go on to assembly programming, then interfacing and memory and so on. Towards the end, we will also go on to operating systems and maybe some examples as well. So this is the main lecture area components. We may also have some practicals, some online lab activities as well, if possible, some type of activities, and there may be addition to these lectures, those will also be there. And there's a main reference book and a couple of other books as well. It is not expected to have those books, but it would be useful for you all to have the book or have a copy of the book. You could maybe even get it online for you all to help understand some of the things that we discuss as an additional reference material. The main areas we will cover in the lecture, but the book may be helpful there as well. We may also have some weekly or fortnightly, or in various frequencies, we may have some online quizzes. So these online quizzes will be based on a topic area that was covered in a particular lecture. So say we may cover a particular topic area next week, and we will have a online quiz after that. Normally it will be a short quiz, a short time limited quiz. You may be given a particular time frame, you have to complete that, and then Mostly it will be short answers or a single question, single sort of a one paragraph question, or few short answer multiple choice questions. So it may differ. Sometimes we may even have some other types of small assignments and so on. So there could be a variety of continuous assessment that may happen throughout as well. So it may be available online, and then you'll have to do them. And when talking about them being available online, and the information or the request on there were a number of chat messages about asking for lecture slides. So the plan for lecture slides is I will normally probably towards the end of the day I will post it on the course page here. Only the lecture slides will be there. It is a sort of a static page where I publish all the lecture slides. I still don't have access to the KDU LMS, and I don't have a particular way of accessing the KDU LMS. I'll talk to the course coordinators and see if we are able to use that, and then we may use that. But for now, what I would advise all of you is to go to this Google Classroom and join the Google Classroom, preferably using your personal emails, personal Gmail accounts. You may join this Google Classroom using this particular class code. So you go to Google Classroom and go to and join. You could join the class there. So then I will be able to share announcements and lecture slides and all the relevant materials directly on the Google Classroom, and I think that is a much more easier way of distributing things. And we can also have our online quizzes posted there as well, so it would make things easier on an ongoing manner. So I would please note down this class code and please join into that Google class. So other than that, are there any other questions? There is something that we can have as part of this course. Interactivity would be very useful, and if you have any questions, and particularly you have the advantage when we are having these online lessons, you can easily ask questions through chat as well, so you don't have to speak in the class, speak out in the class if that is an issue sometimes we face in person classes. At least for the few weeks we have these online lessons, we will you could try to participate in that manner as well. So that's mainly it for today. If there are no other questions, we may conclude our lesson, and we could start around the same time next week. And as I said, the information will be posted on Google Classroom, and I will try to share other relevant information through your course coordinator as well. So thank you for joining in today's online lesson, and we will start, we'll see next time, next week in our usual lecture time. Thank you and bye.
Thank you.